Okay, good evening, everybody. This is Paul, NO0T, at the Front Range 6-meter group in the Deep Space Exploration Society. Ta-da. And today we have Bill Miller, who's going to be giving us a presentation. He's the Vice President of the Deep Space Exploration Society, and he's going to tell us all about deep space and how we use the site we have down in Haswell, Colorado. So with that, Bill, would you please go ahead and share your presentation?
Okay. There we go. All right, this is a nice shot of the Milky Way and some of the surrounding small towns that are 40 miles away, these sky glows that you see. And this was taken during the Perseid meteor shower, and the guy just happened in one frame, in one shot, in the 30-second exposure, caught two meteors right above the dish. So I thought that was kind of cool. So what are we doing down there in Haswell? I'd like to thank Ray Ubrechen, Gary Aggernaut, Myron Babcock, Dr. Richard Russell, Bob Haggart, Dan Lane, Paul Sobin, and others for providing all the information that's in this presentation. We've been doing this I've been in the group for about 9 years, and this is probably about the 5th iteration of this. I take this as an open house presentation. We are having an actual open house on October 5th. So if you can all come down and visit us in person, that would be great. This is kind of the information that you might miss if you didn't come to the open house, but also some information that you wouldn't get even if you did come to the open house. So this is the technical part. So the DSES, the Deep Space Exploration Society, we own and operate a 60-foot radio telescope dish near Haswell, Colorado. It's about 5 miles south of the small town of Haswell. Haswell has less than 100 people. And if you remember the name Haswell, Haswell was the name of the Intel processor back about 10 years ago that was the premier Intel processor. And they took that from the name, the Haswell name of the Colorado town. As you can see, there's my Durango parked in the shadow of the dish. Gives you some idea of the magnitude of this dish. It's 60 feet across and it's about 65 feet tall to the apex when it's in this bird bath position. Also shown in this picture is our current communications trailer or operations trailer with the solar panels on top. And that's our new building in the background. We'll get into that a little bit more. So the Deep Space Exploration Society is a Colorado-based nonprofit 501c3 organization. It's dedicated to radio astronomy and the advocacy of space exploration and radio education for students, the general public, and for the society and group members. We strive to continuously update and improve our facility, radio astronomy, and amateur radio capabilities to benefit the society members and the public education. Give you a little bit of history about the dish itself. The goal of the original research that the dish was built for was to compile a standard communication handbook of accurate reference material so that any group that desired to establish a long-distance communication system would have all the data necessary for the site selection and the construction of the system. The study of the sites lasted from about 1958 to 1974. So what that means is the government built this as a research facility. It wasn't really intended for any true active communication mission other than for the research to figure out how to do it. The information gained from that communication study and research was used in the Distant Early Warning Radar System, or the DEW line. And if you look up White Alice, that was the system that was actually installed on the DEW line for the communications between sites on the DEW line and from those sites down all the way to Colorado to NORAD. The Haswell site construction was underway in about 1957. Part of the land was leased, and then it was expanded and purchased by the government in 1963 through eminent domain. The Haswell site was operated until 1974, when it was made obsolete by satellites and fiber optics and then it was abandoned by the government and surplused and put up on government auction. This is what the site looked like in 1972. There was a 500-foot radio tower with an elevator inside of it, and that was used for VHF propagation studies to figure out how far television stations could be placed from each other on the same channel. And this is back in the days of analog television, but that was one of the research projects that they undertook at the site. And then there you can see the dish and big towers for the three-phase power that came in. There was three-phase 900 amp service that came into the site to run amplifiers and such. And all of that was taken out and no longer available. So the site was made for tropospheric scatter. So because microwave is a good medium for high-speed data, that's what they wanted to use, but microwave doesn't move around the curvature of the Earth. So to get around that, they use tropospheric scatter. And what that does is you have over here, like at the T1 position, you have a dish. You push that energy off into the horizon, light up a volume of atmosphere at the horizon about 30 miles away, and then you have another dish looking back at that same volume, and you can receive that signal as the radio bounces off of the atmospheric particles and the atmospheric moisture. And by doing that over and over again, each one of these stations could be placed, 300 to 600 miles apart, and they could still communicate. And if they set up a system, a relay system all the way around, they could get all the way to Alaska with that kind of a tropospheric scatter communication system. Now let me tell you a little bit about the DSES. So DSES, they were originally formed in 1991 in Boulder County. The members started restoring two identical dishes to the dish that we own that were placed on the T21 or T22 site up North Table Mountain, about 10 miles north of Boulder. There was considerable success with that facility. They used the talents of the professionals and university students to refurbish those dishes and get those dishes running. Unfortunately, Table Mountain is a secure government site. And sometime after 9/11, more conservative management closed the site for amateur use, and the DSES needed to find a new home. So that brings us to the Haswell site history. The Haswell site lay dormant from 1974 when the government abandoned it until 2009, and it fell prey to the elements, vandalism, and theft of most of the infrastructure copper. So the original large three-phase overhead power lines were removed to facilitate farming around the site. And sometime during that period, from 1974 to 2009, we're not quite sure when, a gentleman named Paul Plishner, who was a prominent radio and microwave engineer and contractor to the government, saw this on government auction, and he purchased it sight unseen. He probably realized after a period of time, sending some of his people out to inventory the site and take a look at what was done, he probably said it was impractical to restore it, and he offered it up for sale for a number of years, but he found no buyers. So what happened was the DSES group in Boulder and Longmont, they had to leave the Table Mountain site, so they asked Mr. Plishner if they could be the custodians of the Haswell site and do some restoration. And he agreed and provided them with a no-cost lease, and they moved the operation communication trailer and some of their equipment down to Haswell. And they abandoned the two-dish system up on Table Mountain. So since that time, they've been working very hard. We've all been working very hard to restore and modernize the dish. I'll say one other thing. The original Boulder team, they were about 4 hours away. And so for them to work on the site, they needed to travel the 4 hours there and back, which made it almost impossible for a single day excursion. So they'd bring campers down and they'd do that. But after a while, most of them actually aged out or burned out doing this. And after getting quite a bit of success, they decided to kind of, I wouldn't say they all decided at the same time, but they each kind of fell away from the project. And about 2000, a little after 2009, some of our people here in Colorado Springs started getting reconnected with that group. And so most of the people now are from Colorado Springs, the people that actually work on the site. So after a period of time, Michael Lowe, the group president at the time, asked Mr. Plishner if he considered donating the dish to the DSES organization, and Mr. Plishner did. He originally gave us a no-cost lease, and then he just gave us the whole facility. We still have a portion of the facility that belongs, or of the site property, that still belongs to the Plishner family, but for the most part, all of our operational area is owned by the DSES. So for this generous donation, we named the site the Paul Plishner Radio Astronomy and Space Sciences Center. He passed away in 2016, but his generosity is still greatly appreciated by the organization, and his legacy will live on for many years as the site is brought to full operational status as a space science and radio discovery educational center. Let me stop right there. Any questions about the site history? Okay. Let me go on to the dish itself. So here's the specifications for the dish. It has a frequency range of about 400 megahertz to 2 gigahertz, but we actually believe that based on the geometry of the dish surface and the size of the holes of the mesh in the dish, 10 gigahertz is possible. It's 60 foot in diameter, has a gain of 42.5 dB at 1 gigahertz, and has a beam width of about 0.8 degrees at 1.2 gigahertz. So when we operate at 1296, we've got a beam width of about 0.8 degrees. So if you think about the aperture that you need for the moon, I think the moon is about 0.4 degrees in size, and so most of our energy when we do moon bounce goes right past the moons, which is kind of interesting. It has a very low noise temperature. It has full hemispherical and tracking control, so we can point in any direction and straight up. We can't go over the zenith completely, but we can go 10 degrees past zenith. And we have about a 40 degree per minute max slew rate. We never operate at that. We usually run it a lot slower because the celestial sphere and the moon operate pretty slow, and we don't generally track satellites. So we try to run it as slow as possible to minimize the wear. The maximum deviation of the surface from a true parabolic shape of this dish was specified at no greater than a quarter inch at any point in the dish, with winds up to 30 miles an hour, and that's with any position of the dish. So they had to build it very strong, and it had to withstand, high winds and a lot of bad elements out on the eastern plains. It says when properly stored in the stove position or the bird bath position, it should be capable of withstand winds of 120 miles an hour with a maximum radial ice formation of 3 inches. So that's a pretty incredible spec, and that tells you how strong this thing really is. Here you can see the infrastructure, all the beams and everything. This is most of these tubes in this superstructure are 8 and 10 inch aluminum tubes. It's all heliarc welded together to government specification. So everything above the collar here that sits on the pedestal is aluminum, and everything below that is steel, and the axles, of course, are steel. But for the most part, this is all made out of aluminum and heliarc welded. There you can see where Ray is working on one of the struts. You can see the holes in the aluminum plate. The aluminum plate is about 3/16 of an inch in thickness, and the holes are 1/4 inch on about 1 inch centers. And you can walk on this surface and it doesn't distort the surface at all. It's sat out there in the Eastern Plains for 60 years and has no hail damage. So that brings us to power. When the group took over the site in 2009, there was no power. It had all been taken out. So they installed solar panels, batteries, inverters on each of the facilities. These batteries in the top right-hand corner are actually in the bunker. There's a bunker on site that has about 1,500 square feet of interior space. And we have the battery in the pump room. There's sump pumps in the pump room. And the batteries are a backup to the sump pumps, because when we lose power, or we lose solar, you got to have enough power to keep the system dry. And this bunker is about 14 feet underground to the floor, and it floods quite often. And without the sump pumps, we would be in a world of hurt with the equipment. So back in about 2017, the site was trenched, and we installed a 2.5 kilowatt or 25 kilowatt propane generator in this shed, and a propane generator sitting on that trailer right there. It takes a forklift to lift it into the shed, and they installed that, and that gave us power across the site. So the site was wired in the trench with 3-aught 4-strand electrical wire across the entire site. So there was about 650 feet of wire run across the site, and the generator shack was put almost in the center. Then in 2018, Skip Creeley, who's a prominent RF entrepreneur, he had several companies that he sold. He generously donated the money to bring a single-phase power line over a mile into the site and get us hooked up to utility power. And once that was attached, we had enough 230-volt split-phase power that we could spend a whole lot less time maintaining the batteries, the solar panels, and the generator, and a lot more time doing a radio experience. So thank you, Skip. We'll see a little bit more on Skip a little bit later in this presentation. Then in 2023, I analyzed the low voltage power distribution running the 1,200 feet from the transformer pole at the road. That was the system that they put in with Skip's money. And that comes, we were putting in a new building, so that had to come 1,200 feet down to the new building into the dish. And I found that to be deficient and had excessive voltage drop, as it was a low voltage 230 volt system coming down through the site 1,200 feet. So if we run anything very big, and I wanted to be able to run air conditioning units and heat pumps and motors and all the stuff that takes to run the new building, we couldn't do that with the transformer out at the road. So in September of 2023, we contracted the Southeast Power Association to come down and install 650 feet of additional overhead high voltage line and 600 feet of underground high voltage line to a new transformer at the center of the site near the new building. And that will provide a 200 amp, 230 volt split phase service for the building, and 100 amp service to the underground bunker, and 100 amp service to the comm trailer, with the transformer placed in almost the center of all of that. And that'll solve most of the voltage drop problems that we had before. It was amazing. They sent out, I think it was 7 guys and 7 trucks. You see the picture there, with a trencher and everything they needed to install that. And they worked 3 days to install that. And they only charged us, I can't even remember what they charged. It was ridiculously low. But it was a pretty good deal to get good power brought in. So recent site infrastructure upgrades and projects. These are things that are all new since last year. So we have a new still operations building, the building gutters, drainage, erosion control, restroom and kitchen facilities. PVC conduit runs from the building to the dish and to the roam towers for our radio towers. 280 gallon or 1,280 gallon cistern tank with on-demand water pump, a 500-gallon septic tank and leach field, a new utility power connection with improved distribution loss, a DSL internet connection, and hopefully upgrade to fiber in 2025. The company that does the internet down there and the telephone, I think it's Southeast Telephone. Can't remember the name of the company. Anyway, they're talking about putting in fiber to our site in 2025. That'll be a big improvement. And then and we improved the sump pumps and in-ground flood control. We got security cameras and new parking areas. Any questions about all of that? Okay. So in 2023, or actually 2022, we wrote a grant proposal to the Amateur Radio Digital Communications Group to build a new operations building for the site. This proposal was only 8 pages, but I guess we sold it pretty well, and it was accepted, and the funds were granted for a new building. Due to post-COVID labor and supply chain shortages, the building didn't get underway until well into 2023 and continued to suffer labor shortages, but now we're very close to completion of the building. It's a steel 1,800 square foot building. It'll expand our operations for the comfort of the organization, students, and the general public. They have a radio control room, a classroom, a kitchenette, really, a bathroom, and a garage. This is the layout of the building and a pictorial view of the front. Here you see the radio and dish control room over on the left-hand side of the floor plan, classroom in the middle, the kitchen there, and the bathroom. And one of the stipulations would have had to be an ADA compliant bathroom, and actually an ADA compliant facility. And the only problem I've had with that is getting doors with thresholds low enough to actually meet the strict ADA requirement. But I think we about got it whipped. And then it has a garage over on the far right-hand side. This is a few pictures of the building being put up. We had a group from Clovis, New Mexico. 4 guys came up with 2 big diesel trucks pulling big flatbed trailers. They brought everything they needed. They pulled up. This is after the first half day at sunset. They got there about noon and had this much up by sunset on the first day. That's the second day, third day, still the third day, and then it was finished on the third day. So these guys, 4 guys put this thing up, didn't miss a screw in actually basically 2.5 days, and put it all together. But that's just the bare metal building, and which kind of looks like this picture here. It did not include the box within a box, which I call the box within a box, which is the bathroom and the kitchen, just the metal structure and the siding. And we had that spray foam insulated on every surface, all the interior walls and exterior walls. And then I devised a way of doing the wall paneling with minimized framing and minimized materials for cost. And we covered all that spray foam except for the ceiling, which we left and painted white. And that's what the inside of the building looks like now. So that gives you an idea of where we came from and how we got there. So we're about ready to move all of our equipment in here, and we've got racks that go into these conduits on the floor, and we've got all the material we need to really outfit this and make it a operational center. That's what the outside looks like. And we've got a nice parking area. We've got to put some railroad ties along here so people don't run into the uprights that hold up the front awning. So that brings us to the radio and the radio astronomy upgrades that we've done with the site. We've got a remotely operated amateur radio station provided by Paul Sobin. Paul generously donated that, and I'll get into that a little bit later here. We've got two new Rome 55 tower bases on either side of the building. We've got a 400 watt EME transverter by Alex Ners. I can't say his last name. Sorry, Paul. You'll have to tell us how to.
Mercian.
Nersian, yes. And he did a great job on this 400 watt EME transverter. You'll hear that in a minute. We can do celestial and moon tracking control with an upgrade from we had 12-bit encoders, and now we're up to 16-bit absolute encoders, and so we can track down to a thousandth of a degree. We got ionospheric scintillation experiment with the University of Texas in Dallas. An experimental interferometer with twin 3.8 meter dishes. We've got that in progress. We've got all the electronics and one of the dishes so far, and we got to pick up the other dish here before winter sets in and get that installed. And we recently acquired a 30-foot additional dish and a silent key cell, and that'll be erected on the site next year. And so we'll have the 60-foot, the 30-foot, two 3.8 meter dishes all on site, ready to go. This is the remote operated station from it's K0PRT that was donated by Paul, and it is full remote control over the internet, all HF and 6-meter bands, all mode, all full power, SDR enabled, and software automation of the equipment and the logging. You can see all the screens here and all the equipment under the bench there. All this will be put in a rack in the new building. Right now it's in the bunker. Oops. Then these are the antennas that are currently supporting. There's a tri-band 10, 15, 20 meter Yagi on a 50-foot tower, a 5-band trap vertical out there in the weeds, and dipoles for 80 and 160 meters, and a 6-element Yagi for 6 meters, and VHF vertical on 50-foot tower for 2 meters. I think we've taken that VHF vertical down. It's not currently up there, but we plan to put it back up on the new building. And that's mostly for our talk-in system. The roads out there can be treacherous. We can break down. We've had a lot of flat tires and runoffs the road, and so it'd be nice to have a talk-in radio, so if somebody's still on site, we can have them come rescue us. These are some of the screens for the remote radio station. It takes 8 screens to run the system, or 8 windows to run the system. We do that in 2 screens and 2 monitors, and it's pretty elaborate system. Any questions about the radio system? Okay, I'll move on. Okay, when you do the dish, you have to have RF feed antennas that feed the dish. So we've got like at 1296, we've got 42.5 dB of gain, but we have to get that energy into the dish in an efficient way and get it out of the dish in an efficient way. So what we have are these feed antennas that are basically a chaparral type choke ring antennas. This one has a square resonant cavity for 1420 megahertz, and the other one down here on the bench is for 1296, and it has a round cavity. Ray Uberek, I call him Dr. Radio, he came up with most of these antennas for the dish feeds. The one for 408 megahertz and 435 is these little dipoles out under this structure. The structure isn't the dipoles. The actual 2 dipoles are out in front of it, and that structure is to have a screen backscatter ground plane to prevent picking up from the back side for 408 megahertz. But Ray has devised all these antennas. These are often built out of interesting materials. The one on the table there is a massive dog dish for either a dog dish or a cattle dish. The one up here on the 1420 is a cake pan, and that's the ring there. But by doing these rings, we're able to get the energy into the dish without a lot of spillover, and out of the dish without a lot of spillover, so we don't pick up ground noise and the thermal noise off the ground. And so that helps with reducing the noise and increasing our signal noise ratio. So this is the dish tracking. I'm going to share a different screen here. And I hope this works. Sometimes it does, sometimes it doesn't. Let me play this, and this will give you an idea of how we can track. This is actually tracking pulsars on a foggy morning. And you'll see the fog lift, the pulsars coming. Okay. Yeah, I hope you enjoyed that. That video was done by Mark Slovan, who's one of our members. He's actually was a mechanic, and he joined our group. And by joining our group, he parlayed that into a job with Dish Network up in Wyoming. And so he's managed to figure out a way to do some actual job searching with his videos. He has a website called Road Trip Ventures on YouTube, and does a lot of these time-lapse videos. So let me go back to the presentation here real quick. Okay. This is, let's see if I can do this. Okay, here's what it takes to change out the feed. Are you seeing the dish here with Ray crawling up there?
Yep.
Okay. Ray's going to strap in right here. He's got a climbing harness on, and there's turnbuckles up there on the feed. If he were to fall, that strap would, he'd just dangle there, and the dish would hold him. It's strong enough that it wouldn't even deflect as it carries his weight. But there you can see that he's up on a 35-foot tall scaffolding, and falling is not what you want to do, but that's how we get up there to change out the feed in the front of this, I call it a donut or a tube that's up there. And there you can see what he's doing. This is prior to the building being built. When this pans out, you can kind of see the rest of the site. I might have missed it, but the site has the communication trailer. Just where this is pointed off to the north is where the building is located. And that's what it takes to get up there and change that out. I'm going to jump ahead a little bit on this. And here you can kind of see the site. There's a generator shack. Go out a little further. As we come out further, you see the generator shack, and off in the distance, you can see the bunker. But that's what it takes. Okay. So for radio astronomy, we have the high gain 60-foot dish. We can do hydrogen line, which is at 1.42 gigahertz. It's density mapping of the cosmos. We can do radio Joe, 15 megahertz to 22 megahertz, which is the natural radio signals from Jupiter and its moon Io and their interaction. We can do super SIDS, which is from 3 to 30 kilohertz, which is sudden ionospheric disturbance, and that shows us solar flares and events that change the ionosphere. We can do meteor scatter from 30 to 100 megahertz, and we do SETI at 1.42 gigahertz, search for extraterrestrials at the watering hole. And then we prove that this is possible with geographically space synchronized signal detection with the Green Bank Observatory and Haswell Observatory, and now a new New Hampshire Observatory. So I'll show you that in a minute. With radio astronomy, the atmosphere is it's opaque to some signals, but it's transparent for other signals. So from about 5 megahertz to 30 gigahertz, it's transparent. So anything in that zone we can receive pretty unimpeded. For some of the other frequencies, we're blocked by the atmosphere and the ionosphere. Here's the Skip. This is Skip Creeley, the guy that gave us the power donation. He did this experiment with one of the radio telescopes at Green Bank. It's a telescope about the same size as ours, and we both pointed to the same object in the same part of the sky at the same time and recorded our signal. And what we got and then he married those two recordings in his computer, and what we got was we saw the object cross over the two telescopes at the same moment with about the same amplitude. I can't explain the difference in the baseline amplitude here on one side versus the other, but I think that's the noise difference between the two things. Actually, this is time on the x-axis and amplitude on the y-axis. So I can't quite explain why there's a difference here in the blue and red signals, but he actually did this experiment. And what that tells us is that with two radio telescopes, if we receive a signal at the same moment that's unexpected, this happened to be a nebula that we were measuring. But if we received a signal at the same moment with both telescopes separated by 1,200 miles, that would mean that the source of that signal would probably be outside the orbit of Mars. So that would indicate that it's not something terrestrial or even orbital. It's something that is out there a ways. And so it would either be a deep space probe or extraterrestrials. So far, we haven't received any extraterrestrials. To do a hydrogen line, now 1420 megahertz is the hydrogen line, and we have this special radio receiver called a SpectraCyber. Now we've kind of replaced that with SDRs because the SDRs are good enough now that we really don't need the SpectraCyber. But what this shows you is as an object crosses our beam width, what we can see is this is frequency on the x-axis and amplitude in volts on the y-axis. And anything that shows on the left-hand side of the 0 point here is red shifted, and anything that shows on the right-hand side is blue shifted. And so when looking at deep space objects, we can tell if something's coming towards us, moving away from us, or part of it rotating. Like if it's a galaxy, we can see the rotation of the galaxy by seeing that portion of the arms of the galaxy that are rotating towards us and those that are rotating away from us. And so it'll show up as a signature on the spectrocyber on this graph. So it only measures about 600 kilohertz either side of the hydrogen frequency, which is 1420.406 megahertz. And so what that does is it gives us a very good indication of what's really going on with an object that we're observing. If you don't know about neutral hydrogen emissions, hydrogen is about the most abundant element in the universe. It accounts for about 70% of all the matter in the universe. And it's a component of the interstellar medium. It's in everything. And if we can observe it in the spectral line that I just showed you, and in the Milky Way. So if you looked at it like this sky map here shows the Milky Way in the center going across, and that's the emission from hydrogen. What happens when hydrogen falls from a high energy state to a low energy state? Its electron flips over and a photon is emitted at that 1420.406 megahertz or 21 centimeter signal. And as an individual atom, it's a very small signal, of course. We couldn't even measure it. But since everything's made out of hydrogen, there's a lot of hydrogen out there, it all adds up. An individual atom only changes its jump every 10 million years. So on average, an atom of hydrogen would change every 10 million. Well, would change at 10 million years. But because there's so much of it out there in all different ages, you end up with a lot of signal coming back that we can receive very easily with the big dish. Dr. Richard Russell, he actually performed this experiment where he mapped by changing the galactic latitude or changing the elevation of the dish and letting the Earth scan across the heavens. He was able to, over time, put all of the data from the spectrocyber into a spreadsheet, and he's actually got this map that he made with our telescope that kind of goes back and matches that map right there. So you can actually see the Milky Way galaxy in radio vision across there. Sometimes we use this observable S7. I believe that's Sagittarius 7. It's a stable, bright hydrogen emitter we use for calibration. And it has a unique signature, this triple bump here. And here we used a AirSpy R2 SDR and actually measured that and recorded it and compared it to the calibrated spectrum from one of the professional radio observatories, and you can see that they match up pretty well. And then this is an all-sky map looking at the 21 centimeter, and that's the Milky Way galaxy coming across there. So any questions about hydrogen emissions? Okay. Pulsars are something else we can do. We can receive pulsars. They're spinning neutron stars with massive magnetic fields. They generate sweeping beams of broadband radio emissions. With our equipment, we can't actually hear them, but we can detect them below the noise floor. And I'll show you how we do that in a minute. They're comprised mostly of neutrinos and have a diameter of only about 12 miles. So a typical pulsar is from about 6 to 12 miles in diameter. And they have a mass in a range of 1.18 to 1.97, so about 1.2 to 2 times the mass of our sun. And they're contained in a space only of 6 to 12 miles in diameter. And so that gives you an idea how dense these things are. Here's an example of how we detect them. The pulsar looks like this. It's a spinning neutron star. It has these jets of high frequency emissions or broadband emissions, and when that beam from the spinning pulsar crosses us, we can detect it. And so we get it into the dish, we amplify it, we control the dish to track the pulsar, and we do data analysis on it, and we figure out, and we end up with a signal that might look something like that. So with digital signal processing or folding, we can figure out the pulsar out of the noise. And so we don't actually detect brand new pulsars this way, but if we know of the pulsar, like the ones in a catalog, and there's thousands of them, we can pick out one out of the catalog, point to its location, receive the signal, record the signal, and then fold it based on the known period of the pulsar, and fold that up like a piece of paper here. And if you were able to look through it and subtract out all the things that were different and add all the things that were the same, you'd end up with the pulse. This is an example. I'll play this for you.
Hey, we got it.
You got it? Where? Look, right there. Oh, wow, that's fantastic.
Yay! This is B 1508 plus 55.
New pulsar.
Yep.
September 12th, 2020. Deep Space Exploration Society Pulsar Radio Telescope. Excellent. Way to go. This is number 9.
Okay, I actually lied a little bit there. We don't. I said a new pulsar, new to us. We've actually detected. I think we're up to 22 or 23 pulsars that we've detected, which ranks us as like number 4th or 5th in the world of amateur groups that detect pulsars. And so we're still working on this. As we detect more, we hope to move up that ladder and eventually be number 1 or 2. Actually, the guys in Germany, I think, are number 1. They've got a bigger dish and a lot more time on the dish to do this work. And so it's doubtful that we ever pass them, but we have the capability that we could if we had enough site time. Incidentally, these are different pictures of different pulsars. The pulsar name is this BO 329 plus 54. That's the strongest one right there. It has about a 720 millisecond period. Each one of these pulsars has a different period, and that's really important because if you know its period, you can do the stacking algorithm. And for amateur radio, we can do tropospheric scatter, like I talked about before, EME moon bounce at 1296, HF radio, VHF radio, UHF radio, microwave radio. And we do some tropospheric communications. We just did one about a month ago with Texas, and that worked out pretty well. So we do EME, and we participate in the contest, most of the EME contests. We were 4th place in 2020 for multi-operator all mode 1.2 gigahertz. I think we had about 85 contacts in that one, and we were 2nd place in May of 2023 in DBUS, which is the European, I believe, the European contest. And so we're one of the few stations that can do not only all the digital modes for EME and the CW modes, but we can also do single sideband, and not too many of the stations out there can do single sideband. We usually have about, in any one contest, we might have 2 to 4 single sideband contacts. I don't know if you can hear this. We tried this before and it was a little light, but this is my granddaughter. When we had the open house, we did it during the EME, during an EME transit last September, and my granddaughter came out, as well as many other people. Anybody that wanted to, bounce their signal off the moon. So here she is.
Hi, this is Harper Katie PRT.
You might not have been able to hear her, but you could probably hear the echo. And so that shows you how long it takes for the signal to get to the moon and bounce back. And so it's about 2.5 seconds round trip. I got another one here from, I don't know if I can play this or not. Let's try this. Might have to stop it. Let's see. Huh. I'm going to have to jump out. Let me play this one by Gary. I'm going to only play the first and the last half of this, but Gary made a contact here.
Whiskey 6 Yankee X-ray, Whiskey 6 Yankee X-ray, Kilowatt 0 Papa Radio Tango, Kilo 0 Papa Radio Tango.
I'm going to jump to the end.
And thank you very much for the call. A Whiskey 6 Yankee X-ray, Kilowatt 0 Papa, Radio Tango 73, Jim.
Very good, Gary. Thanks a lot, Gary, for the contact. And we'll also find out there. A0 CRT from Whiskey 6 Yankee X-ray, Stanford University.
Stanford University.
So there you see, made a contact. Actually, I said the wrong thing here. We were only putting out about 180 watts when we did this, and they were about 200 watts. Or actually, we were 200 watts into a 60-foot dish, and they were 400 watts into a 30-foot dish. And that was the Stanford Radio Observatory out in California. So that kind of shows you what we can do. So that brings us to education and outreach. So every year we have an annual open house. Tentatively this year, I'm pretty sure we've locked this down, October 5th, which will have a full moon transit during the day. So we'll be able to do EME all day long on October 5th. We have optical and radio observatory demonstrations. We do judging of awards for the Pikes Peak Regional Science Fair and Technology Fairs. We have publications on radio and radio astronomy that we try to get out into some of the annals. We have the Society of Amateur Radio Astronomers that we participate in, site trips and tours to national radio observatories. We have a website with all our proceedings and articles open to the public at dses.science. We have mentorship of student participants and presentations to amateur radio and other civic clubs. Last year we did an open house barbecue, lunch and classroom seminars, and this was in the new building before we had the interior finished. But we hope that'll be a little nicer this year with the walls all up and everything ready to go, and with the full kitchen. Some pictures of the past open houses. We used to do a pancake breakfast on Sunday mornings if people stuck around. Some people like to come out and camp out with their campers and hang out with us. So usually we're there on Sunday morning, and we pack up by about Sunday noon and go home. But it's a great time out. So if you have a chance, come on down and join us. In education, we do like I said, the Pikes Peak Regional Science Fair. This is a young gentleman, Xander Duvall. He actually took our data on neutral hydrogen and presented a science fair project on it, and took the data and analyzed it and did a whole bunch of research and placed in the regional fair, and then went to state and did really well at the state fair. In 2019, we had Hans Gainsborough, who did a special SDR for radio astronomy and presented it at the SARA Western Conference with about 200 of our SARA members and got a standing ovation from all the senior Sarah. Sarah is the Society of Amateur Radio Astronomers, and these guys traveled all over the world doing conferences, and they gave him a standing ovation for his work on SDRs. And then Dr. Richard Russell usually sets up a pretty good radio astronomy demonstration educational program. And we had a certification program, but we had so few people want to participate in that we've kind of dropped it, but we may pick that up again. So for public outreach, we do annual community events in the area. The area is a very rural and farm and ranch-based area. And so Gary and I have been going out to the Eads Bazaar and the Haswell Bazaar.
Oh, sorry.
And we do a lot of community contacts, or meet a lot of communities contacts. And we make our operations known so people don't have suspicions of what we're doing out there in the middle of nowhere. So that's one of the things we do with our open house, and we do at all these community events. And then, like I say, we participate in the Society of Amateur Radio Astronomers, and it's a good outlet for some of our members to write papers and give presentations and get recognition for the work that they do. We have meetings. We have an engineering and operations meeting every second Monday of the month at 6:30 Mountain Time. And we have a science meeting every fourth Monday of the month at 6:30 Mountain Time. And we have a site work trip standing schedule every third Saturday. But you need to contact a board member for the schedule on whether we're going on that third Saturday. And you can join DSES for $50 a year, full voting membership. And you can join on PayPal at our website. There's a sign-up page and a PayPal join site there, or membership site there. So that's all I have. For more information, you can just type in dses.science into your browser, and everything we do is usually published on that website, and it's got all the archives of everything we've been doing, at least since I've been secretary, or was secretary. So, so there's a lot of information out there and a lot of paper. So that's about it. Any questions on all of that?
Hey, great job, Bill. It was really, I learned a lot. I've been a member now for about 2.5 years. So a lot of stuff I didn't realize we actually did. So you really did a good job covering it all.
Well, thanks.
Yeah, when are you coming down, Peter?
I wish I could. It's been interesting. Bill, thank you very much for this. It's good to get a lot more in-depth view of what you guys are actually doing down there, and it's pretty amazing. You're very fortunate to have something that you don't have to share with anybody.
Yeah. Well, I kind of look at it this way. It's like, two things. One is, when you were a kid, right? You always wanted a compound, right? When you played Fort and you did all those things, right? You always dreamt about having this high-tech compound, like who was the one that was on the Saturday morning programs, and now we've got one.
Yeah. No,
so you got that. And the other thing is, where else would you get to play with something of this magnitude? I mean, you couldn't build this thing for $6.5 million, So it's quite exciting to be able to get to enjoy something of that magnitude with a bunch of people with like-minded experience.
I know exactly how you feel. I don't know whether you're aware or not, but I was involved with the E3 ONT operation back in the 90s at Algonquin Park with the 150-foot dish.
Oh, yeah. That's a big deal.
Yeah, it was a big deal, and still probably the highlight of my amateur radio life. It was quite amazing. There were a lot of disappointments, though, too. On that regard, you mentioned that are you planning 10 gigahertz operation with the 60-footer?
Well, we're going to go up in frequency as we get more capability in microwave. We'll probably do right now we can go up to, let's see, we've got some 4.8 gigahertz receivers. They're commercial receivers and feeds. And so we can do things like track satellites and such with those. It'd be real interesting to look at some of the satellite feeds, commercial satellite feeds with our 60-foot dishes to see what kind of gain we get out of this. So there's that. And but we'll probably do the 2 gigahertz in the 2 gigahertz range, 2.5 gigahertz,
Yeah.
and then go up from there.
Yeah.
But
Alex is working on a 2304 transverter for the dish.
Yeah, there's no question you'd be pretty successful with the at 2.4 gigs, maybe even 3.5 as well. 10 gigahertz, we tried that. Unfortunately, I was not there. It was the only operation at Algonquin we did over the 4 years that I was unable to attend due to a family event. But it was a huge disappointment. There comes a point where the dish gets too big for moon bounce as you go up in frequency, and it would seem that for 10 gigahertz, something in the order of 7 or 8 meters might be the peak size. So you might actually be better off with the 30-footer that you've just acquired for 10 gigs than you will with the 60-footer. So just keep that in mind. I mean, it's worth a try. So the surface of the dish might be still fine at 10 gigahertz. I'm not sure about that, but it's just you start under illuminating the moon, you start getting a lot of weird reflections coming back because you're hitting all the different little surfaces on the small area of the moon that you're actually hitting. And I guess the returns start diminishing as you go up.
Start seeing interference and scintillation and that sort of thing off the moon.
Yeah, and I'm not the expert by any means, but I know that K2UIH, V3ASO, Mike Owen, W9IP were all involved in the 10 gigahertz operation. And it was very frustrating. I mean, they had other issues other than just the lack of signal coming back from the moon. Everybody, I think, was expecting something absolutely tremendous, and because certainly at 1296, which is the highest frequency that I was involved with, I mean, the echoes were S9 coming back with 100 watts at the feet of the dish, and they were just amazing. Anyway, it's just something to keep in mind. The other thing I'll add, our first year up there was it didn't go very well due to some weather-related power issues. It didn't go at all, actually. And but what it did was taught us the need for quick change capability for feeds if you're going to do multiple bands. And I would, if you haven't spent some time trying to make your feed changes efficient, quick, as few connections as possible, connections that are all the same, all that kind of stuff. Definitely worth looking at. It'll pay you dividends down the road for sure. So,
Ray's put some work into that. Originally, he designed a 4-band antenna that we could switch, and it would change instantly. But it had a lot of problems, and most of those things I think could have been solved, but some other members of the group got frustrated with it and decided to go to single feeds. And so what Ray did was he set up a bayonet kind of mounting system where he can change the feed out in about an hour.
Yeah, that's about what we got to doing. I know Mike Owen did most of the feed, and I did both. The two of us did most of the feed changes during the 1993 operation, which was the most successful. That was on 3 bands, 144, 432, and 1296, and being able to do the feed change on a 150-foot dish in an hour made a huge difference. And so it's definitely worth just incorporating into your designs. So
in fact, they were Ray and RC went down, I think it was yesterday, and changed the feed. and that only took them. It didn't even take them an hour. They
Oh,
changed
perfect.
from the 1296 feed to the 1420 feed, and just two of them, and Ray did most of the work, and it was less than an hour. So
Yeah, super.
unfortunately, they also went down Saturday and forgot to take the antenna with them.
That happened.
Nightmare.
So they had to come back on Monday or Tuesday to do it.
Oh dear. Well, yeah, that kind of thing happens, unfortunately. I don't know how many trips I've made up a tower only to get up to the top of the tower and find I don't have what I need. So
That's right.
back
Yeah.
for a wrench or something. So anyways, good talk, and really good to see some of the other things you guys are doing with your outreach programs and everything. I think that's fantastic. And
Yeah.
having the dish at your disposal 100% of the time, essentially, and be able to do what you want with it is huge. And you're able to do that thing, and well worth doing too. Congratulations.
Well, thank you. Yeah.
Hey, Peter, I don't know, did you hear about our project for next year?
I may have. Which one are we talking?
We're talking about it's Earth, Venus, Earth.
Oh, really? Okay.
Yep. We did the signal path loss calculations, and figured with 1500 watts on 1296, and using digital mode 265, we can get digital communications between us and back to Earth.
You're going to find a lot of difficulty finding somebody else that's going to have that capability, though. So.
It's not that hard, actually.
Well, the U.S. military did it years ago. So.
Yeah, that was they're using megawatts, and there's a group in Germany did it in
really?
2009.
Okay.
They didn't. All they did was they're just sending pulses back and forth, and they're able to hear the pulse. And back in 2009, we didn't have WSJT. And we didn't have a lot of other things. So, but they're running 6 kW, and but with digital techniques today, we can bring it down right into the noise.
Yeah,
and
nice.
And Venus has a reflectivity of 0.7. The Moon is 0.1. Because of the atmosphere.
All right.
So, something to talk about in the future. You may want to come on down for that one.
Well, I someday I hope to make it down there. It won't be this year. This fall. It's all about the microwave update down in Vancouver, so I'm involved with that.
Yeah.
And so that,
you're in where are you located, Peter?
I'm right on the U.S. border. Like I can see it out the window behind me here.
In BC.
In British Columbia, about halfway across the province. It's a small town called Grand Forks. Like North Dakota, 2 rivers, 2 bridges, and floods.
Yeah. Well, my brother is in Sumas, Washington.
Oh, yeah. Okay.
So he can see the border from his house going the other way.
Yeah, but he's right down opposite Abbotsford or something.
I'm gonna stop the recording now.
Yeah. So
yeah.